Good afternoon and welcome to Mr Mickleburgh's Maths World. This is the way it is. Today I want to take you through some quick problems in finding the area under a curve for an upcoming test. Now here's a parabola we're interested in. You have to be told it's a parabola really, and we've got to find the area under it. Now there is a slight problem in that we don't know what the equation for this parabola is. If we did, it would all be straightforward. There wouldn't be any tricks at all to this. So our first job will be to find the equation for this parabola. Now there's a couple of things we can note about it. The first is that it's got x-intercepts of 10 and negative 10. That means if I was to expand it out, it would look like this. Certainly, if I was to let y equal 0, which is what you do to find x-intercepts, I would, and solve here, I'll get my x-intercepts of negative 10 and 10. That's for sure. But the problem with that is that it's not telling us how far up or down the y-intercept goes. Okay? So we need to multiply that by some factor which we're temporarily going to call a. The question is, how do I find a? Well, the answer is rather simple. Because I know that when x is 0, I have my y-intercept. And I know what the y-intercept is here, it's 400. In other words, if I was to let x equal 0 and y equal 400, I could then solve for a. So that's the secret to these type of problems. 400 is going to equal a. If I let x equal 0, I've got a negative 10 there and a positive 10 here. In other words, 400 is going to equal a times, now, negative 100. Let's take that out front. Therefore, a will equal negative 4. So that means the equation of our parabola is y equals negative 4, x minus 10, x plus 10. Okay? So that's how we find the equation. Now the rest is straightforward. We need to evaluate a definite integral between 10 and negative 10. Or do we? In fact we don't. What we're going to do, fellas, to find the area is evaluate the area of this part, the right-hand part of the parabola, and times our answer by 2. That'll make things easier because we'll have limits of 10 and 0. 0 is very nice to substitute into our integral. So, now, the other thing I'd say is that this isn't what I'd call calculus-friendly form. We do, if we ignore the negative 4, have what's called a difference of 2 squares, right? So this is going to equal x squared minus 100. So that's going to make it easier as well. So we can say the area is equal to what I said I'm going to do is just evaluate the right hand side and divide my, times my answer by 2. Now I just want to show you something else. That's my difference of 2 squares, which I have to multiply by negative 4. But because I need to multiply my answer by 2, it's going to become negative 8, like so. Okay? Now that's a reasonably straightforward area problem to solve. We now go into the calculus, not forgetting our negative 8 there. Increase the index by 1 and divide by the new index, minus 100x, and my limit is 10 and 0. Therefore, area is going to equal 10 cubed is 1,000. Well, let's not forget the 8. So it's 1,000 on 3 minus 1,000. Now, see that 100 times 10 is 1,000. I want to express it, however, in terms of thirds. So I times 1,000 by 3 and put it over 3. So we've got this sort of thing going on. Okay? And that pretty well is the answer. I just obviously need to tidy it up a bit. I've got negative 2,000 there times negative 8, so it's going to be negative 16,000. Therefore, area equals negative 16,000 on 3 units It's an area, so they are square. So that's that problem there. Now let's try a slightly different one. Okay, a bit of an upside down parabola. But a lot of what we, in fact all of what we discussed in the previous question applies here. So what did we discuss in the previous question? Okay, well firstly, we know that we've got x-intercepts of -2 and +2. But we know that where this y-intercept occurs is going to depend on some scalar factor which we call A. And our job now is to solve for A. So what do? Well, the procedure here is that we know the y-intercept is -100, so we let y equal -100 and x equals 0. Okay? So therefore, -100 equals A, we're letting that equal 0, and we're letting that equal 0. You can probably see quickly enough that -4A will equal that, therefore A equals 25. Positive in this case, which is what we'd expect. If we've got a positive A, we're going to have a U-shaped parabola. So that means that the equation of our parabola is y equals 25, x plus 2, x minus 2. And now, just as we did before, we are ready to integrate that. But again, I'm going to make use of the property of symmetry, and I'm only going to evaluate from where x is between 0 and 2 and multiply my answer by 2. So that means the area equals, okay, 2 to 0. Let's just do the difference of two squares bit. That's the first term squared minus the second term squared. Always minus dx. I'm not sure I had a dx in the previous problem. It should have been there. Now don't forget there's a 25 here, which I can bring out the front. And don't forget I've got to multiply my answer by 2 because I'm only dealing with the right hand side, and to deal with the whole side I've got to multiply that by 2. So that will simply be like so, 50 times that integral. Okay, so what does that evaluate to? Well, there's no new stuff in this. Increase the index by 1, divide by the new index. And to a constant number, you just attach an x. And put our limits in, 2 and 0, and we are nearly there. So, going up here, we have area equals 50, round brackets this time, 2 cubed is 8 on 3, minus 4 times 2 is 8, and therefore area equals 50. Okay, to convert that to thirds, we simply times it by 3 and divide by 3. So 24, 8 minus 24 on 3 equals 50, bracket. 8 take 24 is -16 on 3. And therefore, A equals that times that. Well, you know, it's just 8 times 100, isn't it? Yeah, 8 times 100, so it's -80, no, 800 I should say, on 3. Now, this is an area problem, so we do not have negative areas. Okay? We kind of expect a negative answer here because we're below the x-axis. Some textbooks will put the absolute sides around the integral, like so. But we know that in the bottom line, we don't talk about negative area, we talk about positive area, so we ignore the negative sign and call it units squared. And that's how we do that sort of problem. Okay, we might stop it there.